Hello everyone, in this video we're going to do simplify the expression, and we're simplifying radical expressions. I'm going to give you 3 examples and then you're going to work 3 problems on your own. For number 1, notice this is a cubic root and in the radicand is 8x cubed. Now remember that there is a product property for radicals. Whenever I have more than one factor in the radical, I can separate those into their own radicals. So I can rewrite this as the cube root of 8 times the cubed root of x cubed. I can do that. And now I can simplify the cubed root of 8 thinking what number can I multiply itself by to get 8, and that number is 2, because 2, let me do that down here, 2 times 2 times 2 is 8. Since I used 2 as a factor 3 times, that means 2 to the 3rd power is 8. So the cube root of 8 must be 2. Okay, these operations of cubing and taking the cube root are inverse operations. Okay, so for this one I get a 2, and then whenever you have the exponent, whenever you have that the exponent matches the index, then you can cancel that radical sign and you'll have x as the simplification for this radical. So the answer to this number 1 problem is 2x. Okay, let's do number 2. For number 2, I have the 4th root and I have a quotient. So remember, the quotient property says that I can separate these radicals into their own radical. So I can do this. I can write them separately with their own radical symbol. There it is. And now I simplify. What is the 4th root of 32? I have to think of a number that I multiply times 2 4 times and I'll get 32. Is there a number? There isn't. But I can write 32 as a product of 2 numbers, one of the numbers being a perfect 4th root. For example, I can rewrite the 4th root of 32 as the 4th root of 16 times 2. Is 16 times 2 equal 32? Yes, it is. And then in the denominator, I just rewrite what I had before. There it is. So now that I've rewritten 32 as 16 times 2, I know that 16 does have a 4th root, because I can think of a number that I multiply by itself 4 times and get 16, and that number is 2. If you multiply 2 times 2 times 2 times 2, you'll get 16. That means 2 to the 4th power is 16. So the 4th root of 16 must equal 2. So I can separate these 2 factors into their own radicals. I can write the 4th root of 16 times the 4th root of 2, everything over the 4th root of x to the 4th power. Okay? And now I can simplify. The 4th root of 16 is 2. The 4th root of 2, well, I can't simplify this further because there is no number that I multiply by itself 4 times and I get a perfect 2. So I'm going to keep that one because I can't simplify it. And then in the denominator, notice that the exponent matches the index. It matches. That means I can remove the radical sign and I'll have just an x. And this would be your final answer for this problem. Let's do number 3. For number 3, I have the cube root of this. It's a quotient. So first thing I'm going to do is I'm going to separate it, because the quotient rule of radicals lets me separate the numerator in its own radical and the denominator in its own radical. There it is. So I do that. Now let's work in the numerator. Do I know of a number that I can multiply by itself 3 times and get 125. So I do know of a number. My next step would be to separate 125 and x to the 6th power into their separate radicals. You don't have to do that step. You can just work it right here together if you want. If you want to, you can separate it like we did here where we had 16 and 2 and we separated it. But you don't have to do that if you don't want to. Over here we did it too. It's just to show you the steps, but you can skip that step. So I'm going to skip that step. And I'm going to say that the cube root of 125 is 5 because 5 times 5 is 25, and 25 times 5, that's like having 5 quarters, and that's 125. So the cube root of 125 is 5. And now I take x to the 6th power, and what I do is there's a shortcut we can do here. I can take the exponent, the 6, and I can divide it by 3 by the index. 6 divided by 3, that makes 2. That number that you got, 2, that tells you the amount of x's that I can take outside of the radical. So x squared is what is the cube root of x to the 6th power. And I'm going to show you down here. The cubed root of x to the 6th power is equal to, I can rewrite this as the cube root of x cubed times x cubed, right? Whoops. Let me change that. Because if you remember, the exponent rules, when you're multiplying bases that are equal, you add the exponents. So this is the same thing as x to the 6th power. I've just rewritten it differently, and now I can separate these factors into their own radicals, which is x cubed times the cubed root of x cubed, right? And we know how to do this part. We had said that if the exponent matches the index, then we can get rid of the radical, leaving an x out of the radical. And the same thing here. Exponent matches the index, so that cancels the radical, leaving an x out here. And x times x is x squared. And all of this work can be simplified by just dividing this exponent by the index, which gives you 2, and here is your x squared that you got here by doing all this work. But this just demonstrates why this works, okay? It's a shortcut. So in the numerator we have 5x squared. In the denominator we have the cubed root of 6. Now remember we said that we are not allowed to have radicals in the denominator. And how we get rid of them is by rationalizing the denominator, which means remove the radical from the denominator. Now to do that, I have to multiply in the numerator and the denominator by that radical. But be careful. Since I have a cube root, I can only cancel this radical if I have 6 to the power of 3, right? Let me do that over here. If I have the cube root of 6, I can eliminate this radical only if I have 6 to the 3rd power, which I don't. I have 6 to the 1st power. So how do I turn 6 to the 1st power into 6 to the 3rd power? Well, I would multiply by the cube root of 6 squared. Because now when I do numerator times numerator, I'm going to get 5x squared cubed root of 6. And when I do denominator times denominator, in the denominator, I'm going to get cubed root, since I have the same cube root. Watch what happens. I can put these together underneath the same radical. Just as I can separate them, I can join them back together. So I can write 6, which is this 6 from the first radical, times this 6 from the second radical, which is 6 squared, and that's going to give you a total of 6 cubed. Okay, so in the denominator, I've joined these two radicals underneath the same radical, and I can do that because they have the same index. Okay, if they had different indexes, I would not be able to do that. So when I do join them inside the same radical, let me rewrite the numerator, 5x squared cubed root of 6, and in the denominator, I'm left with the cube root of 6 to the third power, because when I have the same base, we can add the exponents. 2 plus 1 is 3. And now notice that the index and the exponent match, so I can remove this radical. So the answer, final answer, is 5x squared cube root of 6 over 6. And there I've been able to remove the radical from the denominator, and this is your final answer. Now I want you to practice 3 problems on your own, and when I show you the 3 problems, I want you to hit pause so that you can work on them and then come back for the answers. Here are the answers. For the first one, what I did is I separated the factors into their own radicals. So I took 50 and x cubed, and I separated them into their own little houses. Okay, then I separated 50 into factors. I don't know the square root of 50, so I separated 50 into 2 factors where one of them is a perfect square, because this is square root. So 50 is the same thing as 25 times 2. So I wrote it that way. And I also separated x cubed into x squared times x. When I separate x cubed, I'm trying to match the exponent to the index. Remember, when there's no index written here, there's really a 2 here. But when there's a 2, we never write it. We understand that it's a 2, so it's not written. Just like we don't write the exponent 1 when there's an x, but we know it's there. So there's a 2 here, so since I'm trying to simplify it, I want to eliminate the exponent with the index, so I can take x cubed and separate it into x squared times x, which is identical to x cubed. And now I separate 25 and 2 into their own little houses. I separate x squared and x into their own little houses. Notice all these radicals have the same exact index. They're all square roots, okay? Now square root of 25, 5. Square root of 2, square root of 2. I can't simplify that further. The square root of x squared, since the exponent matches the index, I can eliminate that radical, and I have an x outside of the house, and then times the square root of x, which is the square root of x, because I can't simplify it any further. Now, before we give the final answer, notice I have a square root of 2, a square root of x. The same way I separated them into different houses, I can join them together again underneath the same roof. Anytime you have square roots, you group them together and you write them underneath the same roof. So now I have the square root of 2x right there. And then 5 times x, 5x, and this would be your final answer. For number 2, we followed the same procedure. Here, I can very quickly divide 8. 8 divided by 4 gives you 2. That eliminates the radical and gives you x squared. Okay, so I did that first step. This one here, I can separate into 2 factors, x to the 4th power. I'm trying to match the cube root, so I'm going to write x cubed times x, which gives you x to the 4th power. So I've just rewritten this differently so that I can match the exponent to the root. Once I do that, I can separate these factors into their own little houses. I can have x cubed underneath their own house, and I can have x under its own radical also. And this x squared, just keep carrying it down. Here, since the exponent matches the index, this radical I can eliminate, and there is the result, is your x. And for this one, I can't simplify it further, so I keep it. Now I multiply x squared times x, which is x cubed, and inside the radical, I have the cube root of x, and this is your answer. For the third exercise, this is a quotient. So we said that we can separate the numerator into its own radical, here it is, and the denominator into its own radical, making sure to keep the same index in both. There it is. Now, to simplify this, I'm going to match this exponent. I want it to match with the index. So I'm going to write x cubed, and then times x to the what power will give me x to the fifth power, which was the original number, x squared. So I've rewritten x to the fifth power as x cubed times x squared, which is x to the fifth power, okay? And now, I've just written the denominator again. I'm not working with the denominator yet. Then when we continue here, I'm going to separate these into their own radicals. That's what I did here. X cubed, cube root of x cubed, and the cube root of x squared. I just separated them. You don't have to separate them, but just to show you step by step. And the denominator I'm not working with yet. Since the exponent matches the index, I can remove this radical, and what comes out is an x, and here it is right here. Here I can't do that. The exponent doesn't match the index, so I have to keep the cube root of x squared. There it is right there. And the denominator is right here. Okay, so I've kept this one intact, and the denominator also I've kept intact. And from here, now I'm going to work with the denominator by rationalizing the denominator, which means multiplying the numerator and denominator by the same radical. But since this is a cubed root, I can only eliminate a cube root if I have 4 to the third power. And I do that by multiplying this by 4 to the second power, okay? And that will eliminate the radical. And I'll have a 4 in the denominator, and that's what I wanted because I don't want radicals in the denominator, and here's your final answer. I hope these examples help you. I'll see you in the next video.